Okay, what I want to talk about right now is the sampling distribution, and uh, how the variance of a sampling distribution changes as we take more and more samples and to try to compute, let's say, the mean value of some distribution. So um, the idea is really quite simple. We have some random quantity. It could be the mileage for a particular brand of car. It could be the value of houses in a particular neighborhood or something of that sort. And the idea is that we are given a nominal, or let's say a theoretical probability distribution with a certain mean and variance, and we want to take a few samples. We don't want to sample the whole data set, because the whole data set potentially could be thousands or hundreds of thousands of components. We want to take a small sample and then use that to estimate the mean value, and then and try to determine if that is a reasonably good estimate of the mean value. The idea for computing the mean from a set of samples is pretty straightforward, in that we just take the average of the sample value. So if we have x1 plus x2 plus x3, we add them up, divide by 3, and compute the average, and we use that average of those sample values as an estimate for the mean. Now, for computing the variance, or the standard deviation of the samples taken, it's a little bit more complicated. Here we work on the assumption that if we take, for example, 3 samples, and there are 3 samples from a distribution, each has a variance shown here given by sigma squared, shall we say, then we know that if we have 3 independent samples from a distribution with variance sigma squared, that the variance of the sum of those 3 independent samples is simply the sum of the variances, or as we show right here, it's equal to sigma squared plus sigma squared plus sigma squared, or 3 sigma squared for the n numbers. So the variance of the sum of the 3 samples would be n times sigma squared, as shown right here. Now, the mean is 1 over n times the sum. Remember, that's how we compute the mean. We add them up and divide by n. So the variance of the sampling distribution mean would then be 1 over n squared times the variance of the sum. So 1 over n squared times the variance of the sum, which is, in this case, is 3 sigma squared. So what that means then is, if we take for n numbers, the variance is n sigma squared. We divide by n squared, and we get then that the variance of the sum is just equal to n sigma squared divided by n squared, or sigma squared divided by n. So that's the variance of the mean. And then to compute the standard deviation, we take the square root of that, and the square root of this quantity right in here is just simply equal to this expression right in here, or sigma divided by the square root of n. So the result is that the variance on our estimate for the mean, that we compute using the 3 samples, or the n samples we have taken, is then sigma divided by the square root of n.